Hello, you're welcome to today's class. In today's topic, I would like to lecture on the general overview of machine learning. So permit me as I take you through this slide. So first, let's look at the learning outcomes. So in this video, you'll understand the fundamentals concept of machine learning. And second, you'll be able to learn the different types of machine learning and the pipelines involved in building and deploying machine learning framework. And thirdly, you'll be able to gain knowledge of different machine learning algorithms and their applications, such as regression, classification, and clustering tasks. Now, first, let's discuss what is machine learning. So machine learning is a subset of AI where computers are programmed to learn from data and improve their performance over time without any explicit need to program. Now, rather than being told exactly what to do, the machine is given data and uses pattern or insights from the data to make good prediction. So machine learning is critical for technology like self-driving cars, recommendation system, just to mention a few. Now, what are the key points of machine learning? Now, I want you to understand that it learns from the data set by recognizing patterns in that data set, and through that, it makes decision. The second one I want you to also know is it is not explicitly programmed. So unlike traditional programming, where every rules must be coded, machine learning is not like that. Now, let's take for an example. You're training a computer to recognize whether an email is spam. So all you need to do is to feed it the data set, and it will be able to classify such images if they are spam or non-spam image based on the patterns being recognized. Now, the next one I want to talk about is the real-world importance. So machine learning helps to improve automation, accuracy, and efficiency across industries. And it's also essential for developing intelligent systems like fraud detection in banking sector, and also in the diagnosis support for healthcare. Now, types of machine learning. Now, we have majorly three types of machine learning, being supervised learning, unsupervised learning, and reinforcement learning. So let me take you through each of them. So we start with the supervised learning. As you can see in the image, it has to do with labeled data, where we have the data and the annotation together with it, and then which is being trained on models to give a certain prediction. Now, in supervised learning, the machine is provided with labeled data, meaning both the inputs and the outputs are known. So the goal is just to learn the mapping from input to output so it can predict the output for new unseen data. Now, for example, if we are predicting the house prices based on feature on like the number of houses, the size of the house, the number of room, the location, certain facilities, if the house has or not. So those can predict how much will be the cost of the house. Now, what will be the process in such scenario? The thing machine is supposed to do, the machine is supposed to supervise during training by providing both the input and the corrected output label. So it learns from the correct answer, similar to how a student learns from a teacher. Now, in supervised learning, we have regression and classification. Now, let me talk about each of them. Now, when we talk about regression, we're talking about continuous value, whereas for classification, we're talking about discrete value. Now, let's see an example of regression. Now, if we are to predict stock market development, for example, if we have the input to be past price, we could use it to predict what will be the next price as our output. So we can see the graph here showing a continuous value, which is one key about regression tasks. Now, moving on to classification tasks, one key thing you need to understand is talking about classes or category. Now, in this case, classification is another branch of supervised learning. And like I said, the attributes are discrete classes. Now, when we have two classes, it's called binary class. But when we have more than that, it's called categorical. Now, in this case, we are trying to recognize face in this image. So all we need to do is to impute image patches with a face, and then we should be able to predict whose face is that. Is that face of Luke, Mark, or Happy, or Grace? Now, so let's see the next one, which is unsupervised learning. For unsupervised learning, there you could see different images, which is the input data, being passed to the model. And then we are able to tell which class will be for each of the image as the attribute. Now, for the machine learning, it's giving input data without any label output. So the machine is just to find patterns and relationship in the data on its own. So this is typically used for tasks like grouping similar items together, which is popularly called clustering. Now, example of this is maybe in the banking sector or financial marketing, where we have to do a segment of customers based on their behavior, likes, and other things. So in this way, we will be able to put these customers in groups, also called clusters. Now, what is the process? The only thing the machine needs to do is to learn without any supervision and try to recognize the data based on similarities or differences. Now, the third one we have is the reinforcement learning. Now, we could see an image here which has to do with internal states. So learning rates, inverse temperature could be the parameters, the hyperparameters during training. And here we are trying to observe, taking note of the actions, and if this cat is able to do the particular task, it's giving a reward, otherwise it's penalized. So let's see more about reinforcement learning. Now, the machine learns by interacting with an environment and receiving reward or penalty based on its action. So our goal here is to maximize the reward over time by learning the best action to take in different situations. Now, what example do we have here? For example, if you're playing a game, what do you notice? It's either you're giving more mark or a deduction. So that tells us about the positive feedback, which is the reward for winning, and the negative feedback, which is penalty, reduction of mark for losing. Now, the process, it is like learning from experience, where the machine learns by trial and error to achieve the best output. Now, machine learning framework. So whenever you want to carry out a machine learning project, it is very important you understand the framework. That means the pipelines where it takes you on each step, what you're supposed to do in each step. So let's dive in. Now, in machine learning framework, it starts by collecting the data set. Now, we have to find out where is the data set. Is it a private data set or a public data set? So from this image, if you're considering public data set, you could look at official websites like UCI, Kaggle, just to mention a few. And once we collect these data sets, we are going to process this data set, do the feature selection, split the data, train the data with the recommended or the particular machine learning models we want, and then we try to evaluate it, by checking the performance of the model, and then to be able to understand why the model was able to give such a prediction, and from that we can make a good decision. Now, let me dive in to explain each of this process. Now, let's start with the first one. The first one being the collection of data sets. So this is the first thing you need to do. You need to get your data sets. So like I said, it could be public data sets from companies, it could be private data sets, or even the government data sets. So when you collect these data sets, it is a very important step, and maybe you're curious to find out why is it important. Now, the quality and the quantity of data significantly impact the model's performance. So without good data, even the best or the sophisticated machine learning algorithm can fail. So the next thing we want to look at will be examples. Like if we're looking at public data set like malaria cell data set, we can get that on Kaggle, and we can use that for our classification tasks. Now, the next process the next step will be to analyze and process our data. Now, once you get your data sets, the next thing you need to do is to clean and prepare it. So these steps ensure that the data is ready to be used by the ML models. So this helps to take care of outliners, missing values, try to normalize and rescale the features, and also to balance the classes, the class distribution if we're dealing with classification tags. And also it helps in our encoding. That means converting categorical variable into numeric formats. Now, you might be thinking, why do we need to process the data? Now, it's simply to understand that most raw data, to be precise, are messy or incomplete. So if we process these data sets, it will ensure that your particular models can learn effectively from the data without being misled by irrelevant or unnecessary information, and thus boosting the performance of the model. Now, the key techniques. So what way can we go about processing our data? Now, issues like handling missing value, what do? We could fill in the missing value by using imputation methods, or we could just delete. That means removing incomplete rows or column. Now, another one we could consider here, the technique is looking at rescaling. So if our data set is far apart, it's very important for us to standardize it or normalize it within a particular range, which is commonly between 0 to 1. Now, 0 could stand for the mean, while 1 could stand for the standard deviation if we're talking about standardization. Okay. So next one is encoding. So what do we do in encoding? We try to convert categorical variables into a numeric format. By a good example of that is one-hot encoding. So let me give an example. If we are to classify set of people, we could say boy or girl. Now the boy, we have to convert it as 0. While the girl, we have to convert it as 1. So this one-hot encoding helps us doing coding to achieve that. Now, the next thing we have to look at in the phase of the machine learning pipeline is the feature selection. Now, why feature selection? We are going to dive into that. So first, I want you to understand that feature selection is about identifying the most important features or variables or characteristics now in your data set. So why do we do this? We do this in order to reduce the computational cost of the model, and also this helps to enhance the accuracy by just focusing on the important feature that can help to predict that task. Now, why it is important is that if we include too many irrelevant features, it will increase our computational cost and even cause what we call overfitting. Now, there are certain techniques we could use to carry out feature selection. Now, one of it is the recursive feature elimination, shortly known as RFA. We have Baruta, we have Lasso, and many more. Now, the next one I want to talk about will be the data split ratio. Boom. This is an important part in our machine learning pipeline. Now, once you have finished processing your data set, the next thing you need to do is to run the data split, which has to do with training and testing sets. Now, you could use any value based on the percentage for your training and for your testing. We could see various percentage like 70-30, 80-20, 85-15, 90-10. This tells us how many percentage was used for training and how many percentage was used for testing. Now, what do I mean by that? For instance, if you have 100 numbers of your data sample, if you say 70-30, it means that we are going to use 70 samples for training and use 30 samples for testing. So this model is trained on the training set and evaluated on the testing set. Now, this helps us to see how generalized our model will be when it comes across new unseen data. That means data that has not been trained before. Now, why do this data split ratio matter? Now, one thing is that if you split the data sets, it ensures that the model doesn't just memorize the training data, but being able to generalize well to new examples. Now, the key methods, there are majorly just two. One of it is the train test splits, which helps us to divide the data into the training and the test sets. And then the second one is the key fold cross-validation. Now you can see the word there, key fold. It means that our K can be in different folds, such as 5-fold, 10-fold cross-validation. Now let me talk more about this key fold. This tells us how the data is divided into subsets. So for example, if you have K being 5, it means we're talking about 5-fold, which is what? 5 subsets. So we are dividing our data set into 5, which will help us to ensure robust performance evaluation. Now, the next thing I want to talk about is the almighty machine learning models. Now, after you split your data set, this is the time we need to train the model. So we have to apply different machine learning algorithms to make prediction. Now, we need to try different models to be able to tell which model is the best for that particular task. Now, this model can vary depending on the problem we are trying to solve. For example, if you're trying to do classification tasks, you will know the model to use. If you're trying to do regression tasks, you know the model to use. And if you're trying to do clustering tasks, you know the model to use. So let me give you an example. If I'm doing the regression tasks, I will look at linear regression. If I'm working on classification tasks, I could consider SVM. And if I'm looking at clustering tasks, I could consider K-means. So that is what it means. All put together, they are machine learning models, but they are being used for different tasks. Now, why it matters? Now, choosing the right algorithm is very important, as different models may perform better for different type of data and tasks. So for example, if I'm doing a clustering task, I can't take classification model for it. No, it's not going to perform well. It's going to face issue of bias and overfitting. So please make sure when you want to take up any machine learning model, pay attention to the task you're trying to achieve. Now, common algorithm, we have here KNN, we have SVM, we have decision tree, we have random forest, we have tax stacking, we have voting, we have SG boost, we have LG boost, LGBM, and many more, just to mention a few. Now, the next stage is model evaluation and tweaking. So after building the model, it's very important to evaluate the performance using the appropriate metrics. So this ensures that the model is making accurate prediction and allows for adjustments. So now you've trained your model, you've tested your model. The next thing you need to do, you need to check the performance of your model. So for example, if you are doing a classification task, you need to use certain metrics to check how good is the performance. Now, why this matters is that it evaluates the model on unseen data, ensuring that it's not just performing well on the training data, but it can generalize to new unseen data. Now, key evaluation metrics. Now, the key evaluation metrics you're seeing here are for classification tasks. Please don't mix it up. Now, for classification tasks, we could use accuracy, we could use precision, recall, which is also called sensitivity. We could also go ahead using F1 score. We could use ROC, AUC. We could use Confucius metrics. We could use specificity. And we could also use time as an advantage. Now, remember I said these evaluation metrics are being used for classification tasks. Now, think about it. If I'm to work on regression tasks, what kind of metrics should I use? Think. Okay, so not to waste your time, we could use metrics like MAE, which is the mean absolute error, MSE, which is the mean square error, R square, RMSE, which is the root mean square error. So these are the 4 common evaluation metrics we could use for our regression tasks. Now, the next thing we want to talk about will be model tweaking or tuning. Now, maybe you're wondering, tweaking? Yes, tweaking. So most times, if your model doesn't perform well, all you need to do is to tweak the model. what are you doing? You're trying to change the parameters. Parameters such as the batch size, the airport, the learning rates, so many hyperparameters, hyperparameters you could tweak. Now, this is to help you boost the performance of your model. Okay, yes, so this is a very important part you should consider. And often initial models are not perfect. So when you iterate on them through evaluation and tweaking, it will lead to improve accuracy and generalizability. Okay, so next we have is the model explainability. Now, techniques like SHAP, which is commonly known, help us to understand why a model makes a particular prediction by showing how different features contributed to the final output. So this is especially important when using complex models like neural networks or random forests, where prediction can be hard to interpret. This is one of the key things, especially in the medical sector, the expert wants to see. So when a prediction or a diagnosis is made using machine learning, they want to understand why. So we use as model explainability to be able to tell why that particular prediction has been made based on the various features that contribute to that final output. Now, let's move on to the next thing. Why does it matter? So in field like finance, healthcare, it is very essential to explain why a model made a certain decision to build trust and ensure accountability. Now, sharp visualization. We could use different plots to visualize this. Now, one of it is waterfall plot. Now, waterfall plot just shows the contribution of each variables in making a specific prediction. Now, we have the first plot, which is to visualize how features push the model output higher or lower from individual prediction. We have dependence plot, which is to tell us relationship between a single feature and then the model's attributes. Then we have bar plots, which shows the global importance of features across the entire data set. Now we have summary plots, which gives us which feature are most important and how they affect the model prediction overall. Now we have more plots like swarm plots and many more, just to mention a few. So these 5 are very common in what we use currently. Now, real-world application of machine learning. Now, first of all, let's look at healthcare. So we use machine learning in medical diagnosis by analyzing patients' data to detect disease earlier or more accurately than human or experts. So it's also used in personalized treatment plans by analyzing patients' history. Now, for example, if we are to analyze medical images to detect anomalies like tumor with higher accuracy than human radiologists. Now, number 2 we could consider is finance. So take, for an instance, the bank or the financial sector. They are going to use ML to detect fraudulent activity in real time by just analyzing patterns in transaction history. Now, one good example is the credit card companies automatically flag suspicious activity for further review based on ML models. Now, another real-life application we could look at will be marketing and e-commerce. So we use ML in companies to be able to personalize their marketing strategy by predicting customer preference or suggesting products. So this has to do with how we can reduce customer churn and how we can increase retaining the customers. Now, example will be using recommendation algorithms such as people like Baidu, Netflix, Amazon, companies like Baidu, Netflix, Amazon will use recommendation algorithms to suggest movie and products based on human behavior or preference. Now, another one we have is self-driving cars. So ML models are used to analyze sensor data, maybe from cameras or radar, to help autonomous vehicle navigate, avoid obstacles, and even make driving decisions. So example, like Tesla autopilot system will use ML to detect lanes, cars, and pedestrians. Now, thank you so much for listening. So if you're just joining this video for the first time, do not forget to like, to subscribe, and to share with your loved ones. And don't forget to hit the notification bell so that you can get notified when I upload a new video. Thank you so much for watching. I'll be signing off now. Bye.